my name is Erin McDonald and I'm a 5th grade teacher at Tawnytown Elementary, and today I'm going to help explain how we show patterns of numbers when you're multiplying them in powers of 10. The first thing I like to start with is a visual, so we use digiblocks, and I ask my students to create any figure that they want to create. Here I've made an example of one, and it's worth the value of 15 because I have one 10 and then my 5 ones. Now, showing a power of 10, the first question that I pose is how can you make this same figure 10 times greater? We have a discussion and we like to find that if we take our 10, making it 10 times greater, we'll replace it with 100. Now how do you make your ones 10 times greater? You would replace them with the 10. So we make the same exact figure with just larger digiblocks. So that way they can see that the value has changed, but it still looks very similar. And now I'll show you how we explain that with numbers. If you take a look up at this chart, I've underlined powers of 10 in pink so you can see the different exponents and that exponents and powers of 10 are basically the same thing. Now when you're multiplying 15 times 10 to the power of 1, it's equivalent to 150. 15 times 10 to the power of 2 is equivalent to 1,500. Now, a different way to think about that is you're multiplying 15 times 10 once, so that equals 150. When you get above 1, sometimes it gets a little confusing. So we like to explain it as 15 times 10, but our power is twice, so we multiply it again. Now we know that 10 times 10 equals 100, so essentially you're multiplying 15 times 100, and that gets you the answer of 1,500. You can see the growth in the pattern here, and we want our students to recognize the pattern first, not just how to multiply. So if we take a look, the first thing the students are going to say is, you just add a 0. That's always what the students say. But we want to show them that you're actually increasing by a shift in place value. Every time you multiply by 10, you're shifting one place value. So if you look down here, I wrote up our common misconception that you just add a 0 to the end of the number when you multiply by a power of 10. I like to squash that conception by asking if 15 times 10 to the second power is 1,500, does 1 5/10 times 10 to the second power equal this number? And the answer is no. Because you can see here that actually 1 5/10 has the same value as this number, because these zeros aren't really holding a place value. Now another way I like to show that is by using a place value chart over here. So we're going to use what we know from our previous charts up here to explain 15 times 10 to the second power and 1 5/10 times 10 to the second power. I like to tell them to apply the exact same rule they know. So if we know that we're shifting twice, because our power of 10 tells us twice, and we know that each time we multiply by 10, we're going to shift one place value. We take our 10, we replace it to our hundreds, and then replace it to our thousands. That's similar to what we did with our model. And then our ones, we replace them with tens, like we did with our digiblocks, but we're going to go one place further and replace to our hundreds. And since we can't leave these place values blank, they're held by a 0. So our new answer is 1,500, just like our previous chart up here said. Now if you're taking that same pattern that we talked about and you're going to apply it to a decimal, and we know that we cannot just add a 0 on to the end of it, we're going to take our 1 and we're going to shift it twice, because that's what our power tells us to do. So we'll take it from our ones, we'll move it to our tens, and then again to our hundreds, and we'll mark that. And then we take our 5/10, we move it once to our 1 spot, and then again to our 10 spot, and we mark that there. Just like our whole number, we can't leave our 1 space blank, so we have to hold it with a 0. So our new answer is 150. I hope this helped kind of explain a couple ways that we like to show in our classrooms how a pattern by multiplying by a power of 10 is actually increasing by a shift in place value.